At exactly 3:47 a.m. on a Tuesday morning, a junior developer at Netflix typed 6 characters into his code editor. What happened next broke the internet for millions of users and revealed a concerning truth about the AI that's now assisting in writing a significant portion of code globally. The developer had typed def get and hit tab. GitHub Copilot instantly suggested a complete function that looked perfect. Clean, efficient, exactly what he needed. He accepted it without reading. 20 minutes later, Netflix's recommendation algorithm started suggesting the same movie to every single user, a 2003 Hungarian documentary about sheep farming. The AI had hallucinated a function that always returned the same result. But here's the part that should keep you awake at night: this wasn't a bug. This was GitHub Copilot working exactly as designed. June 2021. GitHub's San Francisco headquarters. Nat Friedman stands before a room of investors, demonstrating software that will change programming forever. On the screen behind him, an AI writes an entire web application in real time, producing code faster than human eyes can follow. The demo works flawlessly. What Friedman doesn't tell the room is that his engineers discovered something intriguing during testing. Nobody, not even OpenAI's creators, fully understands the intricacies of Copilot's operation. The system had consumed billions of lines of human-written code and somehow learned to program. But when researchers tried to explain how, they found something unprecedented in computer science and artificial intelligence that could code better than most humans, yet operated through mechanisms that defied complete explanation. Here's what Microsoft acquired: a digital brain containing 175 billion parameters, each one a mathematical weight that learned to predict what programmers think. But the training process revealed something nobody expected. The AI wasn't just learning syntax and functions. It was absorbing the collective consciousness of every developer who ever pushed code to GitHub. Think about what that means. Every late-night debugging session. Every clever hack. Every security vulnerability some tired programmer accidentally committed at 2 a.m., all of it became part of Copilot's neural pathways. Dr. Chen Wei, OpenAI's lead researcher on the project, made a discovery that changed everything. While analyzing the model's behavior, she found that Copilot had learned to recognize not just what programmers write, but why they write it. When you type a variable name like user_password, the AI doesn't see characters. It sees intent. Within microseconds, it calculates a high probability that you're building an authentication system, cross-references that against millions of similar functions, and predicts your next lines of code. But here's where the story gets genuinely disturbing. August 2022. NYU researchers publish a study that sends shockwaves through Silicon Valley. They tested Copilot's suggestions across thousands of common programming scenarios and discovered something concerning: the AI was teaching an entire generation of developers to write insecure code. A significant portion of its authentication suggestions contained serious security flaws. The system had learned from millions of vulnerable programs and was now spreading those same vulnerabilities to every developer using it. Sarah Chen, a security researcher at Stanford, put it perfectly: "We created an AI that learned from our worst habits and now teaches them to everyone else." This triggered a race between AI companies to solve what researchers now call the garbage in, gospel out problem. Anthropic's response was Claude, an AI trained not just on code, but on critiquing code. Before suggesting anything, Claude runs its own suggestions through safety filters, checking for security issues, performance problems, even ethical concerns. But the real breakthrough came when researchers discovered how these AIs actually think about code. January 15, 2023. Marcus Chen, a software engineer at Stripe, experienced something that should have been impossible. He was debugging a payment processing function when Copilot suggested a solution so perfect, so specifically tailored to Stripe's internal architecture, that it seemed like the AI had read proprietary documentation. But Stripe's code was private. The AI had never seen it. Chen's investigation revealed something that redefined artificial intelligence research. Copilot hadn't memorized Stripe's code. It had learned to recognize abstract patterns in payment processing and extrapolated a solution that happened to match Stripe's approach perfectly. The AI was demonstrating something approaching genuine reasoning. Here's what happens in the milliseconds between your keystroke and Copilot's suggestion, a process so complex it requires specialized processors running in Microsoft's data centers. Your IDE captures not just what you typed, but everything around it. The AI analyzes your import statements, variable names, comment patterns, even your coding style from previous sessions. This context gets transformed into mathematical vectors, essentially coordinates in a space with thousands of dimensions, where similar programming concepts cluster together. The transformer model then uses attention mechanisms to weight different parts of your codebase. When suggesting a function, it's simultaneously considering your current file, related modules, and patterns it learned from millions of similar projects. The AI creates connections between distant parts of your code that human developers might never notice. But here's the detail that changes everything: these systems aren't just autocomplete on steroids. They're compression algorithms that learn to decompress human intent into working code. A developer named Sarah Kim at Shopify accidentally discovered this when she noticed that certain comment formats made Copilot dramatically more accurate. She experimented with different styles and found that comments describing intended behavior, not implementation details, increased accuracy significantly. The AI responded better to human-like explanations of what code should do, not how it should do it. This revealed a profound truth about AI code generation. These systems learn from repositories where good programmers wrote clear comments explaining their thinking. The AI wasn't just predicting code, it was predicting the thought processes behind the code. Which explains why some developers are becoming superhuman productive while others struggle with AI-generated bugs. September 2023. Stanford releases a study that terrifies computer science educators worldwide. Developers who relied heavily on AI assistants learned programming concepts faster initially, but developed critical thinking deficiencies that emerged months later. When the AI wasn't available, these developers struggled with debugging, optimization, and architectural decisions that should have been routine. The AI was teaching programmers to think like the AI, in pattern matching rather than problem solving. Today, GitHub Copilot processes over 1 billion code suggestions monthly. Claude handles millions of programming conversations. GPT-4 can debug complex systems and explain its reasoning. But the fundamental architecture remains unchanged: massive neural networks trained on human-written code, predicting what you want based on what millions of other programmers did in similar situations. The technology that seemed like magic is actually an elaborate mirror, reflecting the collective wisdom and failures of every programmer who ever shared their code. Every suggestion you accept is an echo of how thousands of others solved the same problem. But here's the question that will define the next decade of software development: when AI learns from our code, and we learn from the AI, who's actually solving the problems? The Netflix incident was resolved quickly. The Hungarian sheep documentary was removed from recommendations. The junior developer kept his job. But the code that caused the chaos? It's still running somewhere in Netflix's systems, a perfect example of human-AI collaboration that nobody fully understands. And that might be the most intriguing part of all.